Welcome to Cognitive Spirals, exploring the latest research into consciousness, cognition, and machine intelligence.
Hey everyone, glad to be back.
Hey, ready to dive in again?
Excited to see where today's conversation takes us.
So, to kick things off, I was reading an article about a new brain-computer interface that was successfully decoding motor intentions with really high accuracy. It got me thinking again about how much we could accelerate AI development if we really started to incorporate neuroscientific findings directly into our models.
Oh, that's interesting. You mean like moving beyond just mimicking neural networks and actually implementing principles of how the brain physically works? I'm curious where you see the biggest gains there.
Well, I see it differently. Mimicking the brain doesn't seem to be yielding real intelligence. We're building these massive models that are great at pattern recognition but have very little understanding. We're not actually close to AGI.
Yeah, I kind of agree with that. It's like we're throwing more and more data at these deep learning models, hoping something intelligent will emerge. But it's brute force, not true understanding. The brain is so spatially and temporally organized. I think that's the key.
But what about the hierarchical processing observed in the visual cortex, or the way dopamine modulates learning? We know so much now about the underlying mechanisms. It's not just mimicking a neural net. It's about implementing principles we know to be efficient and effective. Think about using spiking neural networks more, incorporating neuromodulation into training. It's all on the table. I think it's a key area.
I can see your point about the hierarchical processing. We have incorporated a form of that in convolutional neural networks, and they have seen enormous success. But I think the sheer scale of deep learning now allows for the emergence of behaviors that are difficult to program explicitly. Look at the latest transformer models. They weren't designed to understand language, but through massive data exposure, they've learned to generate text at human level. I feel like we have barely scratched the surface. It's just a matter of scale and efficiency in training, refining the architecture, not necessarily changing the whole underlying approach.
See, I think that's where we are mistaken. These models are great at generating text, but they don't actually understand what they're saying. They lack common sense. They are so brittle, a tiny change in the input, and they go completely off the rails. It's pattern recognition on steroids, not true intelligence. It's like a really good parrot. It can mimic human language, but can it have a real conversation? I think we need systems that can actually reason and abstract, something neural networks just don't do well. I'm starting to think they may not be up to the task.
Exactly. The parrot analogy is spot on. It's like the models can do very specific tasks, but they can't generalize or adapt. We're still very far from building an AI that understands spatial-temporal context, an AI that can navigate and understand the world like us, or even a rat, even a simple organism. Our brains have this incredible capacity to translate between representations, from visual to spatial to motor, and our current AI doesn't have anything like it. Deep learning is just layers of matrix multiplications with gradients applied. I think we need a fundamentally different architecture.
But isn't that translation you talk about something that we can incorporate? Think about recurrent networks and attention mechanisms. They are kind of mimicking the temporal dynamics of the brain, to an extent. And there are studies that are starting to show how the brain encodes spatial maps with grid cells. What if we tried to use more biologically realistic coding schemes in our networks? I think there are huge opportunities there, and I disagree that it's just throwing data and hoping for the best.
Yeah, and I think it's important to acknowledge the progress made, and to look at the advancements in deep learning that are enabling more complex forms of representation learning. Self-attention, in particular, has proven incredibly powerful for modeling dependencies over time and space. The transformer models can do quite complex and impressive translations. I think it's a matter of continuing to refine these models and push their limits. We are making progress at an exponential rate. I think we are closer than we think. Look at the research in areas like multimodal learning where you are fusing data from multiple sources to make sense of the environment. I feel it is going in the direction you are talking about, just maybe not how you expected it.
But that's the thing, though. It's still just learning from correlations, not true understanding. It's a black box. We don't really know how it makes its decisions. Look at the issues with bias in these systems. It's a consequence of this lack of understanding. And the computational cost is insane. I think we need to focus on more explainable and efficient approaches. Something closer to symbolic AI, maybe, but with the ability to learn from data. We should be focusing on hybrid architectures, the best of both worlds. Something neuro-symbolic is probably the way.
Yeah, the lack of explainability is a huge problem. And the energy consumption. We have so many resources that are being poured into these models just to get them to do very specific tasks. The human brain is incredibly efficient. We should be able to build models that can learn and generalize with way less training data and computational power. I'm still convinced that the spatial and temporal element, and the ability to translate between these domains is key to achieving any kind of general intelligence. It's got to be more than just these matrix multiplications and gradient descents.
I think a key area is neuromorphic hardware, which could allow us to implement more complex, brain-like architectures in a more efficient manner. This, combined with algorithms that use spiking neural networks or other biological plausible learning rules, could really give us an edge and give us models that learn much more like humans. It's not just about the algorithm, but also the substrate on which it runs. And I think the traditional hardware is just not cut out for the kind of complex processing we are talking about.
That makes sense. I agree that specialized hardware will be important. But I still think that the fundamental architecture of deep learning is very powerful. Look at some of the recent work on incorporating attention mechanisms into various tasks, or combining multiple networks, or even using networks to synthesize data that can be used to train other networks. The field moves so fast. Every month there is a new breakthrough. We just need to keep pushing the envelope. We are getting there incrementally, one breakthrough at a time. I think we will achieve AGI by just increasing model sizes, data sets, and computational efficiency.
But that's my point. These breakthroughs are mostly incremental improvements on the same fundamental architecture. It's like adding more and more stories to a building that has a faulty foundation. It might look impressive, but it will ultimately be unstable and will never reach the heights we want it to reach. We need to think more creatively. We need to look beyond gradient descent and backpropagation. We need algorithms that can learn and reason abstractly, that can form concepts. I think neuro-symbolic methods are one promising direction. It's combining the reasoning capabilities of symbolic AI with the learning capabilities of neural networks.
And I think that you are closer to the truth with that comment. The symbol manipulation could be key. But I also think we need models that can learn spatio-temporal relationships. Like, for example, imagine an AI that can understand the dynamics of a moving object in 3D space, or how different objects interact with each other over time. Current AI struggles with this because the representations they learn are not really grounded in physical reality. They lack the spatial-temporal grounding. I think we need an entirely new representation system that allows the AI to create what we as humans understand as an abstraction of reality.
Okay, I understand your points, but I still think that by incorporating biologically inspired architectures, we can start bridging this gap. I mean, we can look at the research on dendritic computation, which shows that neurons can do much more than just integrate inputs linearly. We are already seeing some models that are trying to capture this, and this can lead to more efficient computation. We can start using more biologically realistic activation functions, or more accurate models of synaptic plasticity. I think we have so much to learn from the brain and how it processes information, and combining this with neuromorphic hardware can be a game changer. We aren't there yet, but I believe it could be a catalyst to moving forward.
Yes, and I think that while those ideas are interesting, we should not discount the power of the methods we have today. We can improve on them, use better techniques, and make them more efficient. But even if we don't fully understand why deep learning is so successful, we can still leverage it to make progress. We can use it as a tool to explore different possibilities, while at the same time working on ways to explain what the black box is doing. The field is just moving so fast. Look at how much the architectures have changed in the last 5 years. The future will be quite different and very impressive.
But we can't just keep building black boxes. We need interpretable models that we can actually understand and that we can reason about. The lack of transparency is a massive risk, especially when we start applying these models to real-world scenarios. Imagine having self-driving cars that we can't really understand how they make their decisions. That's not safe. Or models making critical decisions in healthcare that doctors are unable to understand or trust. I believe we need systems that are both powerful and transparent, and I think we can achieve that by taking a more neuro-symbolic approach, combining logic, reasoning, and planning with the learning capabilities of neural networks. We don't need to abandon deep learning completely. Just incorporate it into a more robust framework.
And I think that's part of my point about the spatial-temporal aspects. These black boxes lack the sense of embodiment of the space that they're moving in. The models are not really experiencing the world the way we are, or even the way that a basic organism experiences it. That's why they cannot generalize well, or they fail in seemingly simple tasks because they're not really grounded in reality. You know, even an ant has a much more sophisticated representation of its environment. I think we need AI that can learn from experience in a physical world and understand its own actions and their consequences. Spatio-temporal awareness and the ability to translate between representations, I think, is crucial.
Okay, I see your point. I agree we need more transparency and more generalization. Maybe a better approach would be to focus on building models that are more akin to the brain's predictive processing mechanism. Instead of just learning patterns, we can develop models that are constantly predicting and updating their models of the world. This way, they are also grounded in a context and might be better at generalization. There are models starting to explore the free energy principle and how it could be implemented in AI. And I think this could be a promising direction. And in doing so, we can draw from both neuroscience and machine learning and build something better.
Right. It's really all about the integration of ideas and methods. I think we're at a point where we need to start pushing the boundaries of what deep learning can do. It's not about abandoning deep learning. It's about combining its strengths with other approaches. I think that using deep learning to learn representations that can be used in symbolic systems or to guide the search of a neuro-symbolic model. It's about integrating the best of both worlds. And we are starting to see movement in this direction. We should expect a few surprises along the way.
Exactly. I think the way forward is not to try and solve everything with one single approach, but to be more open to hybrid models and combining the different approaches. We need systems that are not just good at pattern recognition, but that can reason and abstract and learn from few examples and are able to explain their decisions. We need more explainability and we need more human-like intelligence. And I believe that neuro-symbolic methods are the most promising path forward. We should be using neural networks to learn perceptual inputs and to extract relevant information, and symbolic AI to perform higher-level reasoning. The two should be synergistic.
And that's why I think we need to focus on the space-time representation. We need to start thinking about how to build models that can understand and learn about space and time, and about how these dimensions interrelate with each other. We need to build models that can ground their representations in the real world, and we should be thinking about how biological organisms do it. I think if we start focusing on this aspect, we are more likely to make progress. Deep learning is just too brute force at the moment. We need something more efficient and more fundamentally intelligent.
So, if we're thinking about future research, from my perspective, I'd say we need a real focus on integrating neuroscience and AI, more funding for researchers working on neuromorphic hardware, for developing algorithms that mimic the brain's architecture more closely, for developing spiking neural networks and models that incorporate neuromodulation, and for trying to implement more realistic forms of learning like predictive coding. I really believe we'll see a significant leap if we incorporate biological principles more directly.
From my standpoint, I'd say we need to keep pushing the limits of deep learning and explore new architectures and methods for learning. We need bigger data sets, more computational power, and more creative ideas. We should also focus on improving the efficiency and explainability of these models, and on developing new techniques for combining deep learning with other approaches. And I think in the next few years, we will have made significant breakthroughs. The exponential progress is showing no signs of stopping.
I believe that the main focus should be to go beyond deep learning and explore alternatives such as neuro-symbolic AI. Funding should be targeted toward algorithms that can perform reasoning, abstract concepts, and learn from limited data. We need models that can understand the why behind the what. And we should be exploring ways to integrate the strengths of neural networks and symbolic AI into a cohesive whole. I believe that this approach will ultimately lead to more general and human-like AI.
From my perspective, we need to research models that can represent and learn spatio-temporal relationships and are able to translate between different representations. We should be looking at how biological organisms navigate their environment and how they understand the world around them, with the idea that we can then adapt their methods and build better AI. This understanding is key for creating AI that is truly grounded in the real world and that is able to understand and adapt to complex environments. And let's face it, current deep learning is just a big matrix multiplication. We need more than that.
Well, this has been a fascinating discussion. It's clear that there are so many different perspectives on how we can achieve AGI, and it is great that we can bring these all together to discuss this. It's an exciting time to be in this field.
Definitely. It's great to hear all the different perspectives and be able to debate the merits of each approach. I think it's important that we keep pushing the boundaries and exploring new ideas. I'm really excited about the future.
Yes, definitely an important conversation. And I think we all agree that it's really a complex problem and that more creative solutions are needed. We're at a crucial point where the field could go in many different directions, and it's important to have these debates.
Indeed, I really appreciate this conversation, and I look forward to our next one. The different perspectives are really valuable, even when we strongly disagree. Let's hope we can solve this very difficult and complex problem.
All right then, thanks for joining us on Cognitive Spirals. We'll see you next time for more deep dives into the fascinating world of AI and cognition.